So for this one, I'm going to ask you to basically create a queue. I actually built out the class for you. So basically make a queue only using two stacks. So we want it to have those four functionalities there. So peek will basically just return the front element of our queue. Pop will remove that element, and then push is just going to add it. So remember, it's first in, first out, but obviously stacks are last in, first out. So if you have any questions, let me know, and then we can get started working through this.
Okay, sounds good. All right, so we're going to be making a queue using two stacks. So yeah, just like how you said, I'm just going to reiterate again. Our queue has the idea of like a waiting line. So the first person there is the first person out, FIFO, as we like to say. And then, but we're going to be using stacks to do this. So stacks have the idea of the last in, first out. So it's like stacking paper or something like that.
Yep.
The last thing you put on is the first thing you take off. So the good thing is that C++ has a stack library, so we can use the functions in there for the queuing. So the way I'm going to do this is the push. We can just use the push command that's associated with the stack class. Same for the queuing, so that shouldn't be a problem. Empty, we're just going to test if it's empty using the stack command, so that shouldn't be an issue. So it's just a little bit more different with this pop and peek. So the way I'm going to approach this is peek returns the bottom element. I'm going to call it the bottom, but the bottom element of the stack. So we can use that in this pop. So we can call peek, and then it'll return an integer to pop, which we can use there. So the logic I'm going to use in this is if we have the numbers, for instance, our stack is like 1. Oh, nope, I do not want that. 1, 2. Oh, wait, what? Okay. I'll just do it this way. 1, 2, 3, 4, 5. So this is the like bottom, I'm going to say, and this is the top of the stack. So we put a 1 in, and that on top is our 5. And that's like stack 1. So if we're going to peek this queue, we want to get to this 1, but we can't get to there without taking off all of these first. So we're going to have this like helper stack. I'm going to call it just stack 2. And it's going to take on, we're going to pop the 5 onto this one. So we're going to say pop this one, pop that one, that one, that one, until we get to this 1. And then that will, then we can pop that element. So like pop 1. And then after we do all that, we need to put it all back because we still want to like refer to this first stack. So then we're going to pop off of stack 2 now, this still being the bottom and this still being the top. So that should work out fine because now we're going to put it back the way we basically found it, just minus the 1. So it's going to end up being 2, 3, 4, all over again. So that's our pop method. And peek will work like very similarly, just it won't pop, it'll just return this value. Yeah, so that's my logic for those two methods. And I think we could probably start implementing if that's all right.
Yeah, why don't you start with peek?
Okay, sure. So we're going to start with peek. Peek is going to return an integer value. So we are going to say, we're going to check if, all right, so we have input and output. I'm just going to call them stack 1 and 2 just for my own personal.
Yeah.
Okay, so first we want to check if stack 1 is empty, because if it's empty, we don't want to bother doing anything. So if not, stack 1, we can use this command. So if it's not empty, then we'll do some things. So while the stack 1 So while the size of this, or no, that's not correct. So until it has one element in it, we are going to push to the second stack. So whatever's there, we're going to push. So stack2 dot push the top of 1. So stack1 dot top. And that makes sense because you can only take the top of stack 1 anyways, and we want to be in order, like reverse order basically in stack 2.
Yeah.
So that makes sense. And then as we do that, we want to pop off from stack 1 so that we have access to that next element. So pop.
Yep.
So that should work for that step. And so we're going to do this until it has one element. And when it only has one element left, then we want to pop that. Oh, wait, no, this is peak. So, all right, so then we have our integer answer once we get to this point. So then we could say, like, int results, I guess, is the top of stack 1. Since there's only one thing left, the top of it is going to be that last element. So stack 1 dot top. So yeah, I'm going to just remind myself that at the end we're going to return this result. So that's great, but now we have to put everything back now. So we need to find stack 1 the way we found it, just without that first, like first in element basically. So we're basically just going to reverse.
Actually, let me ask what is this doing here, line 33? So why are you checking if the input stack or the stack 1 as you call it is empty?
That's just a check to see if it's worth doing this at all, because if that stack 1, if there's nothing in it, then there's like nothing there. So then we can't peek anything if it's empty, you know? So yeah, stack 1 is basically our queue, and if there's nothing in the queue, then we can't peek it. So it's just like a test to see if we should proceed.
Okay.
Does that make sense?
Yeah, keep going.
Okay. So yeah, now we're going to put everything back. So I'm going to say while, so until stack 1, until stack 2 is empty. So while it's not empty, we're going to do this. So stack 2 dot empty. So until stack 2 is empty, meaning this temporary helper stack 2. So until that is empty, we're going to put it all back. So we're going to push to stack 1. So stack 1 dot push the top of stack 2. So whatever's on top, we want to put it back, and that way we will be reversing it. So top spelling, and then pop it off stack 2 because we don't need it there anymore. So all right, so now our stack 2 is empty, and our stack 1 will have everything back in place the way we found it, just minus that. Or no, it'll be back the way we found it. This is peak, so we're not popping anything. So yeah, it'll be back the way we found it. We should be fine. Yeah. So then we're going to return our results, which would be an integer value. And yeah, so that's our peak. Then we're going to use use peaks in pop because we end up recycling a lot of the same code. Just to cover these, I'm going to do this. All right, what is this value? And we're going to push to stack 1 because we want to build up stack 1 for the way we're going to implement. So stack 1 at push value, and then just to fill these in, empty, we're going to say this is a bool value, so return stack 1 dot empty. Nope. Okay. We don't need that. So if it is empty, then it'll return true. Do we want it that way? If it is empty, return true. So yeah, okay. So yeah, we'll do it this way. Yeah, great. So here's our peak, and now we have to fill in for pop. So similar to peak, we can take this information. So no, we don't actually want to actually cycle it. So the only difference between peak and pop is that pop removes something and peak does not. So the way we will do that is, let's think. So peak will return the front of the queue, and we want to remove that in pop. So to do that, the short way would be to well, like in theory, we could just repeat all this code and remove the result concept. And then just say stack dot pop or stack one. Pop the top and then put it all back. So that would work, but it's just not the most elegant way to do this. Yeah, so yeah, I guess the point is that this, I think, will work in my opinion, but there's definitely a way to combine these. I just, right now, a bit of a problem seeing how they could interface. Yeah, my one issue is this middle piece here. Yeah, so this, I think, yeah, just to sum it up, I think this would work. It's not the most graceful way, but it is a solution.
Okay. Yeah, so I think this is, I'm just trying to follow your peak here. I think this will work pretty much. The general idea is there. I mean, you talked out the logic, which is what, we really care about. So yeah. Any questions? We won't go over runtime and everything like that. But do you have any questions for me with this one?
No questions. Did you want me to explain my logic here? Is there something that isn't super clear? I can explain it if you want.
Yeah, if you don't mind, just this part here. I understand this part. Yeah, why don't you just explain this just once over for me?
Yeah, sure. So our test is going to, so stack one is the one that has elements in it. And we're going to say that while it has a size, while that size is greater than one. So the reason why we're testing it to be greater than one is we want to push onto the second stack until there's one element left. So with this inner loop here, we're going to say, we're going to push the top of stack one onto stack two. And then every time we do that, we want to remove that element we just moved so that we can access the one under it. So as this while this goes through, then we're going to be moving down stack one, basically. So yeah, and that back to that reason of going until we have one left is when we do have one left, that is like that front element of our queue. So that's why we're testing for it to be negative. Greater.
Okay, I think, and then you just put it back on again here.
Yeah.
Okay, yeah, that makes sense.
All right.
Yeah, well, good job.
Thank you very much.